Yeah,
Hey
thanks
John,
for
welcome to show.
well, thanks for having me. This is great.
Yeah, we were talking on Reddit and now we are continuing talking here and it's great to have you here in the show. And by the way, John is the writer of the book Learning Go. And maybe we can start from, you can introduce yourself and we take it from there.
Sure. Jon Bodner, a software engineer, been doing this for seems like forever at this point. Working as started working professionally around '97. Um, Go has been the language I spent a lot of time on for about the last decade, but I've written in tons of languages over time, lots of different places. Um, so yeah, I did a lot of Java, did SQL, JavaScript, Python, Ruby, Objective C. I think I once did a slide for a conference talk where I did like 20 different languages that I've used at some point in my career or in school. So done a lot. The language is less important than the process and the engineering behind it. One of the things I try to encourage when I wrote Learning Go is explaining why I do things in certain ways. And one of my former bosses realized I was sneaking in basically a book on how to do software engineering instead of a book on a programming language. So that's been kind of my focus. How do you write good code? What does it mean to do that?
Okay, and currently you're working also in some company, I'm assuming.
Actually, currently taking a break. I left
Oh, okay.
Datadog early September.
Okay.
Been taking a
Mhm.
break. Trying, may just do writing. I haven't decided quite yet. What's next for me?
Okay, sounds good. All right. So actually, I'm curious about how did you get into programming in the first place?
So yeah, this is story. So June 1981. I would just finished second grade, I think. And friend of mine, his father was a teacher in New York City public schools, and he was a math teacher in New York City. Was trying to introduce the idea of computers in the classroom, and he brought home this thing. And so me and my friend Keith were going to go outside to play some baseball, and his dad's like, "Come over, take a look at this thing." Puts this thing that's called Commodore PET. You probably have never seen one before. And says he goes, turns it on, types in print 2 plus 2, hits return, it says 4. Keith's like, whatever, let's go play. I'm like, wow, this is the most amazing thing I've ever seen in my life. We just did addition and subtraction in school, and like this thing will do my math for me. It was great. Kind of fell in love with it at the moment. His father then taught like a class on basic programming. Took the class on it. They went on a family trip. I borrowed this from him when he had it available over the summer. I had an Atari 2600. He convinced my mom to buy me the basic programming for the Atari 2600, which was terrible. Then got me my first real computer was a Commodore VIC-20. We had our Commodore 64. I taught myself assembly language because no one told anyone when they were 10 years old at the time that you couldn't learn assembly language, so I bought the books on it and learned it. There was a
Wow.
summer program called CTY in the U.S. where you take a test and you go off to college campuses for a couple of weeks. I did Pascal one summer and Lisp another summer. Went to college, majored in computer science, and just
Okay.
kept on doing
Well,
it.
when was the time you were actually writing Pascal?
Would have been I first learned Pascal probably been 1987.
It is. Okay.
Yeah, so I was eighth grade.
I think, yeah, we're going to talk about Go, but I think Go has, like, I also read, like, I started to read the book from the Brian Kerrigan, I guess. I think that they
Mhm.
also schema of the, like, the previous, like, the influences of the Go language, and the Pascal is in the one line, I am assuming.
Yeah, there's some things with Pascal's declaration structure.
Oh, yeah.
There's touches of it here and there for Pascal.
Mhm, mhm.
There's a famous essay, maybe by Brian Kernighan, like why
Okay.
Pascal is not my favorite language, and it
Mhm.
goes through all the weaknesses of Pascal compared to C. And there were some weird ones, like you couldn't have more than like 256 elements in an array ever. But again, it was of the time, and you know,
I
Pascal's
think
kind
it
of a
is
dead
similar
language now.
years, right? The C and the Pascal is like beginning of 70s, I think. Something.
Yeah, yeah. So the C was invented in the early 70s, and Pascal was sometime in the 70s. Niklaus Verret invented it.
Sounds good. So did you work with C as well before?
Yeah, yeah. So actually, my last job, I was doing a little bit of C coding then, but
Okay.
I taught myself C in college. I was like, when I went into college, I knew Pascal, and for the first semester, they said that's fine if you know Pascal, you can use it for some of your programming assignments. But they said you've got to use C, and it was an engineering college, so they said you just learn it yourself. And so I taught myself C and used that most of the way through school, along with Lisp. And then professionally, I've used it a few times in my career. My last job actually, I had to write some shared libraries in C, and so I had dropped back into using it again, which was it was the experience to go back to C again.
Yeah, the, like coming to the actually Go, I think the if you having the background of C, the Go easiness a lot of things for you, I think. But if you're coming from the higher level languages, probably you're thinking why Go is doing things in certain way, and it's a bit of different, like comparing to especially the high level languages like Python and Node.js or TypeScript or any other high level language. If you compare it to Go, it's quite different. But I think those are the solutions if you look at from the perspective of the lower level languages, the problems people come across, like especially writing C, and they come up with some sort of solutions, and that's actually one of the main reasons they wrote Go, I guess. What's your take on this?
Yeah, I agree. A lot of the people who worked on Go, with Brian Kernighan, Rob Pike, these are people who are at Bell Labs. These are people who actually worked on C originally and Unix originally.
Right.
And so a lot of the times I look at Go, it feels like if you're doing application level programming in the 21st century, Go is like the answer to everything they got wrong with C. And some of those things, there was no choice but to get wrong. When a computer had like 4K of RAM, of course, and it had a single core CPUs, no GPUs, no multi-threading, you're just going to write a code differently, right? So given 40, 50 years of additional resources, how do you restructure your programs? How do you restructure your language? Is a lot of what I feel Go has. But even things like the standard library in C is terrible, has very little functionality in the standard library, so it's really limited. There's lots of undefined behavior in the spec, and that meant that when people built C compilers, they all made different choices that did different terrible things, like uninitialized variables, what's the memory supposed to be. The type system in C is really weak. The memory management, of course, like the malloc and free stuff in C is terrible. Tracking memory yourself. No concurrency, of course. No, only English is really supported in C. Like it's really hard to do any other language without using like encodings. So like Unicode didn't exist until the 90s anyway. So of course none of that's in C originally, and there's no standard library support for any of that stuff. So writing a C program like today it's horrible. It's an awful experience trying to write like a modern program that you can trust in C.
Yeah, as you mentioned, the like I don't know that much of C, but to initial value, I think one of the more main problems in C, and the Go is solving this quite elegant way, and many other aspects, as you said. But what do you think about comparing to, like, for example, Java, and maybe kind of lower level languages, but also, I'm curious about what do you think about the higher level languages? Have you used any higher level language before? Like Python or some other language?
Yeah, I did a lot of time in Java, actually. It's a big chunk of my career spent in Java. I spent time doing Ruby for a while, some time, like I said, Objective-C and Python. I've used those before, JavaScript. Java was actually, when I first learned Java, it was the first time that OO programming made sense to me. I'd done a little bit of C++ before that, but like, why would you bother with this? Like, it doesn't seem much better to me than C. And then I was like, oh, Java, having the garbage collector there, the single inheritance. You see these languages like as like a response to their times, right? That's how I look at it. Like Java came out in the mid '90s, and it was a response to the fact that, hey, we have more resources on computers now. You're the first multi-core CPUs or multi-CPUs in a box, and I want to do threading for real. Anyway, so Java had thread support built in. I remember doing threading in C versus threading in Java, and it was like, this is just astounding. I could write a server in like 5 lines of code in Java, and C was horrible. And having garbage collection, of course, to manage my memory for me automatically felt great. Compared to C++ and having to worry about multiple parents and the diamond problem for inheritance, and Java says, oh, single parent, you're fine. That all just felt good, not having like separate header files from your source code. It all worked together well.
Yeah.
The portability was nice as well. But a lot of the things that Java didn't really work well over time, right? Like when Java first came out, CPU speed and memory speed was about the same, and people thought they'd just keep getting faster and faster together, and it didn't really happen that way. And so Java putting everything on the heap, everything is an object except for primitives,
Yeah.
um, is made assumptions that made the garbage collector so important, having had this really fast garbage collector and a lot of control over it.
Mhm.
And then Go comes along in 2010 saying, hey, we've looked at now people running Java code for like 20 years at this point, and here's places where it's kind of falling down for people doing servers. That's, I think, been part of the major adoption for Go is in people who were doing Java who said this has been kind of resource intensive. And I can use something a lot less fewer resources and write it in Go. And the code's simpler to understand because inheritance turns out isn't all that great for most of the time. So why even have it? And exceptions aren't really all that great, so why even have them? To simplify your model of how you develop your code. And Go has been a lot about that simplification and getting back to like what do you actually need to write a program that people can understand and that runs pretty well on a computer.
Yeah, I agree. Like so I think in the book also you're mentioning the Java everything goes into heap, but since there is a JVM and then really strong garbage collector, that's why I think it's still not that performing bad Java. The comparing to Go is like putting things in the heap when it's necessary. It's not always like you have a like local, for example, pointer and you return it and it might go to heap or not depending on situation. And yeah, I think the book is explaining those kind of details very well.
Yeah, and Java can perform really well. Java code and Go code at this
Mhm.
point is about the same in performance, but
Mhm.
the Java memory usage will often be 10 times, 100 times more to achieve the same performance. And the garbage collectors in Java are really complicated and really clever and smart because they kind of have to because so much garbage gets created over time. And there's been efforts in Java to get like more stack allocated types, and I think they're getting closer now. This has been like a 10 plus year project, and they're
Mhm.
kind of getting close now to having value types in Java.
Mhm.
But
Yeah, yeah, those are quite interesting, but I'm curious about also other solutions. Like I think the low level problems and there are different perspective and two of them are the Zeek and Rust. Especially Rust these days quite people are talking about because of the Microsoft also decide to moving a lot of code from the C and C plus to Rust. And also Zeek is, I think also we are hearing some open source libraries are performing very well and I think acquired by Cloud AI. And those are we start to hear other success stories. What are you thinking of? What do you think about them?
so I don't have a lot of experience with both. I've written a few Rust programs, done some tutorials on Rust. I've read through some of the Zig docs before, but I've never written any code in Zig. So I don't. I'll caveat it with that I'm not an expert in either language. Um, and I kind of see why people think of Rust and Go as competitors. They came out around the same time. They both don't have inheritance. They both don't have exceptions. But I really think that they're complementary. There's some different design decisions between the two. There was a blog post written by the Go lead and the Rust lead maybe 5-6 years ago where they say, "Hey, we think our languages are actually complementary, not like in competition." I'll find the link for you. But the way I look at it, like Go is this lower friction language to pick up, right? It's built around it's easy to understand. There are trade-offs. There's some trade-offs in Go still of safety and performance. Having a garbage collector, having nil being there, and having to use tools to find things like race detection. Now they're adding like Go routine leak detection. So Rust was created by Mozilla to create a browser engine, right? And so you're running unsafe code off the internet. You're downloading unsafe images off the internet, and safety and performance now really matter to your browser engine. And so for Rust, it's okay if the code's a little bit harder to understand as long as you're safe and as long as you're fast. And so you get this trade-off. So you're in this lower level, more performant code, but it's harder to understand. Like, in Go, you have a garbage collector solving your memory problems for you. In Rust, you kind of are the garbage collector. You're assigned the lifetimes for each of the pieces of data and saying this is the variable that's able to modify it for now, right? And here's the alias to it that's able to like read it but not modify it and manage that all yourself. And if you do it correctly, the compiler will tell you if you did it wrong. And if it's right, then congratulations, your program works. It's probably safe. Um, Zig, I think, is interesting. Like the idea of like meta programming a compile time using Zig code, I think is kind of fascinating.
Mhm.
Still pretty early for it. Like I said, I hadn't written any Zig code yet. I've been looking at the docs and following along a little bit. Um, I kind of wonder, and I think we're going to talk a little bit more about this later, but AI coding and Zig. I kind of wonder in the age of like AI being used to write code if Zig doesn't have a future because of that.
Mhm. Yeah. Um, AI is gonna change a lot of things, I think.
Hmm.
We're gonna talk about in a bit. Um, yeah, the goal, as you said, people says usually it's easy to start with. Like, so I think it has 25 keywords. Not seems not super complicated, but it has a lot of small details, and those are very important. Like I think the idiomatic part of the book is coming from these details and super important details. Like for example, in the book also there's in the error part, and so errors in the built-in interfaces in Golang, and you can define your own error type, and if you have the like pointer to that error type and in your function, and if you're returning it as an error, the thing is, you have to be careful with that because interfaces are nil only if the type and the value, both of them are nil. And if you're returning the pointer,
Yeah.
then it's not going to be nil. So this kind of small details is actually to making the Go different, putting the Go in a different perspective. Like, I don't think Go is super simple, but it has a lot of details. What do you think about that?
No, I agree. Like this is you can get started in like most languages, like very simple tutorials, just take on faith. Oh, if you follow this pattern, you'll be fine. But you don't really understand like why do you follow this pattern, right? And what those patterns are doing is like, oh, there's actually there's a dragon hiding behind that door, and just don't if you follow exactly this pattern, you'll never see the dragon. But then inevitably, you're going to make a mistake. You'll miss it, like, or you'll ask the question like, what happens if I don't follow it? And all of a sudden, surprise, you understand. Oh, a Go interface has this really weird rule about nil, and it's kind of like this knock-on effect because Go has this weird thing where you can have a nil variable of some type in Go, and I can call a method on it, and it works. Um, the only language with something similar is Objective C, where if you can call if you have a nil type in Objective C, you can call a method on it, and it just does nothing. It just like kind of swallows it. I think it's been like 15 years since I've written any Objective C, but I think that's the behavior. It just kind of swallows the request. In Go, it actually calls the method if it's a pointer method on the type, and if that method can't handle being nil correctly, it'll blow up on you. You'll start getting panics. But if it does handle it correctly, it can handle it correctly, and because of that, having an interface around like a nil variable of a certain type makes sense because of course I can have nil variables because they can respond to method calls, and so you can't have a nil interface where just the value is nil, not the type is nil, because it could actually respond to the methods on the interface. And it's kind of these knock-on effects from features combining is where I think problems start kicking in all not just Go. I'll criticize Go for this one because that's what we're talking about today. But all languages have these places where like features kind of intersect and overlap, and things are hidden. There's this Joel Spolsky. Now this is from like 20 years ago. And I can't believe it's been 20 years. He wrote this blog post called the Law of Leaky Abstractions. And what he's talking about, you build software in different layers, and you hide difficulties in lower layers in those upper layers. But no matter what you do, those lower layers, you can't completely hide them. The pull quote from the blog post is, "All non-trivial abstractions to some degree are leaky." And so that's one of the things you're running into. Like the interface thing is really nice and clean. Nil is a nice and clean concept, but then in Go, oh, nil plus interface becomes a little bit scary. And this is true. I can talk about this for all the languages and where they leak.
Yeah, yeah. Yeah, but in the book also you're saying it's concurrency and Go routines are is the most famous thing in Golang world, but also interfaces. I think because of that, the language itself is coming from 2009, and as you said, the other language is coming from pre-2000 area, and the different needs, different perspectives. But the Go can fix things and what do you think about this perspective from the Go side?
So I think what Go did was kind of clever. So what Go did, I think, was kind of clever. First of all, realizing that the argument against inheritance isn't really new. Like I think I mentioned in the book that the original Gang of Four book from 1995 has the favored composition over inheritance as a pattern. It was talked about by Martin Fowler decades ago also, that you really want to make sure that inheritance really is a relationship. And a lot of the times people in Java use inheritance like a utility functions. I can have some common utilities I want to share across a bunch of different types, so I shove them into a parent class and I use it that way. And the problem is it's not really what it was meant to do. It was meant to a very specific case of modeling relationships of your data and data structures. And most of the time you don't really have that relationship. What you have is I've got some data, and Go has the concept of embedding, which gives like this ability to, like, if there is some shared fields but not some shared type information, then I can suck in those fields. And if there is some kind of shared interface to those fields, type embedding in Go gives you a way to like delegate to that embedding, which is kind of a neat concept. But people try to use like fake inheritance. It's not inheritance. It's composition. It's very much composition and delegation. So this idea, so Go addresses that, I think, in a better way. And Rust made the same choice, that inheritance really looks nice at first, but in practice it turns out not to be as useful as you think it is. And it's kind of unfortunate because I think still today, my kids have taken in the U.S. the AP Computer Science class. They were in high school. You learn computer science and do college level work, and they still teach Java as of a few years ago, and they still teach object-oriented programming. It's like, this is like the way you should program. Like, that's not really true.
Yeah.
Right? It is a technique which has pluses and minuses, but you get hammered into your head early. Oh no, this is the way. It's like, no, not so much. It's a way. And so Go addresses those problems. It was people who had looked back and, they'd never really been very much into OO programming. They were C developers, right? And I don't think any of their other languages really have been very OO. So it was their choice.
And I think is the you can define, actually it's one of the powers coming for the using interface in Go is that you can actually define your interface in the client. It's not necessarily has to be in the, actually this is the idiomatic Go is preferably using in the client, right?
Right, and there's some built-in shared small interfaces like the reader interface, the writer interface, or the error interface, right? With these very core concepts that everyone wants to share, and they're single method interfaces, right? And in Go in general, you want to have these small interfaces because it's type safe duck typing is how you should think of it.
Yeah.
Interfaces in Go, that you are describing that this is the functionality that I need, and give me a thing that meets this functionality, and I can now use it. And it gives me a way to make my code, again, it's making your code more clear in the space where I'm actually looking at the code. Oh, this thing needs this functionality, right? Whereas if I had a gigantic interface that's been defined somewhere else, what am I actually using from it, right? What does this bit of code actually care about from this big gigantic interface? Like Java interface often have multiple methods, many methods, and Go interfaces are meant to be relatively small because you're describing what functionality you actually need to perform the job you're currently doing. And this works nicely. Like this is how duck typing works in Python or Ruby or JavaScript. And the downside being, of course, with other languages, that there's no type checking. So I give it a thing, and I don't actually know if that thing really does meet the interface I need. I just start calling methods on it, and I kind of hope for the best, whether the data types actually match, whether the method even exists. And Go doesn't let you do that. So it's this nice little trade-off here. And I think it helps you evolve systems in parallel much more nicely. It makes your code more testable because I've got a much smaller thing I've got to mock out to test. And I just think it just helps document what your actual intention actually is a lot better.
Yeah, Go is not as object-oriented compared to Java, but still I think they're having a lot of aspects object-oriented programming as well. So it's possible to use some design patterns like decorator, adapter here with the interfaces. Those are completely possible.
Yeah, absolutely. It's got some, like, it has methods on types, right, in Go. So I can definitely. I can actually, in Go, I can keep my data and my methods together as a unified block and pass that through your system, which is part of the concept of object-oriented programming, right? That you want to have pure separation of data from functionality, that you want to have some kind of like association of the two. But it's multi-paradigm in a lot of ways. It's a practical paradigm, really. Like you can do that, but you don't have to do that. And other things you get in OO that they didn't find as useful, they just didn't include, and that's fine. Like, there's no overloading, there's no overwriting, right? You
Yep.
can't have multiple methods with different parameter types on the same with the same name but different parameter types and have it work. I was looking at Swift lately, which has its own kind of fascinating ideas and languages. And in Swift, you can have the same method and the same type, but different names of the parameters, and that actually have it overloaded that way. It's kind of this fascinating opposite way of Go's approach of no, 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 don't reuse a name. It's like reuse as many names as you want as long as there's something that's different about it. And we can now figure it out. So you can have two methods that both take in an int, but the int variable has different names, and so it'll work different. So you can call them individually because the name of the variable of the parameter is actually used as part of the call to the method, to the function in Swift. It's fascinating seeing how different people address the same problem in different ways in different languages.
Yeah. I think the learning different languages helps a lot to see the things in different perspective. That's super useful.
Yeah.
Yeah. So let's go back to a book actually. So I don't have this second edition yet, but so a person who enjoyed reading the first and edition, what are the new things, or what are the differences like mainly in the second edition?
So it's mostly an expansion more than anything else. Second edition came out now 2 years ago. Came out in January, February 2024.
Mhm.
So generics are so the first edition, the first release of the first edition. I wrote the chapter on generics before generics were actually released. I talked with people on the Go team about it, and they said this is what it looks like, and then they made changes to it. And so there's actually a revision of the first edition where the generics chapter has been revised to actually be correct. In the second edition, it's correct. So first things first, that chapter actually is right.
And
One of
tooling
the
changed,
biggest.
I think, as well, right?
Sorry.
So tooling is changed as well. Some.
Yeah, I added a whole chapter on tools in the second edition because one of the part of the difference between Go and Rust is that Rust tries solving things at compile time that Go will solve with tooling. So will lean on linters, Go will lean on like the race detector, now a Go routine leak detector, and the Go mod and the Go workspace and all of the Go environment, the module support is really important. Right, I had talked about modules in the first edition, but in the second edition I started talking more about linting tools, embedding data into your programs, cross-compiling, all these great things that Go has that I just didn't get around to talking about in the first edition that make the Go ecosystem better, vulnerability checking, things like that. Let's see, the change in behavior for for loops. This is like the first backwards breaking change I added to Go, and it was a good decision to do this. That originally in Go, before I think Go 121, 121 and earlier, if you have a for loop and your for range loop, you're looping over a slice or something, that variable gets reused every single time, which is fine, and that's how it worked in C. But in C, you didn't have closures, and C didn't have Go routines, and so the variable will be captured by a closure or a Go routine, and then that same value is now shared across multiple Go routines. You created multiple Go routines or multiple closures inside of a for loop. They all were sharing the exact same instance, and you didn't realize this. And so you had this weird behavior start happening with this shared value, and you didn't realize you were sharing it. And so they put a very clever fix into Go in, I think it was 122, but that's double check me on that, where they said, okay, if the loop doesn't have anything that's going to cause it to leak out, then we'll use the old behavior. But if anything can cause it to leak out, we will create a new instance of that variable every single time through the loop. And now there's no more sharing. But there's a flag. You can, by setting the version of Go in the Go mod file, it'll determine whether this behavior happens module by module, which is also this great way to like slowly ease people into it. So that's covered in the book. I rewrote some examples in there that weren't very good. There was one case where I wrote an example of how to do something in concurrency, and it was towards the end of writing the book. It's in the middle of the book, but it was actually towards the end of me writing the book. And I was tired. I was like, I just want this to be done at this point. And one of my reviewers said, "This isn't a great example." And I was like, "I don't care. This is fine." And then I tried teaching with that as an example. I'm like, "Oh, this example's terrible. This is awful." So I ended up rewriting that code entirely to like do it better. It's in the second edition. One thing people ask for is exercises. They would want to like have checks to see how things were going, And so that's a great idea. So I added exercises at the end of every single chapter, and sample solutions are available on GitHub for all of this as well. I made sure all the code's up on GitHub. The first chapter got rewritten a bit to make it better, make it a better introduction to Go.
Mm-hmm.
Yeah, it's a lot. It's about 100 pages all in all, and
Mm-hmm.
so every chapter was touched in some way just to like improve it.
Mm-hmm. Mm-hmm. Sounds great. Yeah, actually my journey. So I was using in my previous company Go and professionally, but I need to start quick a little bit. So I completed Udemy course. It, as you said, it's not teaching very deeply. It's just how you can use the language and that kind of stuff. But this book helped a lot, and actually for me, a little bit of I realized I changed the stage from the very beginner to close to the like one step up is when I start to understand memory and how it's like structs, slices, arrays, and maps, and all this stuff, how it's handling. And this book actually goes into very well with this kind of details, and that's one good thing. Maybe shortly you can tell to what do you think about memory management in Go in general?
So yeah, this is like that leaky abstraction stuff I was talking about earlier.
Mm-hmm.
That for example, most of the time you don't have to think about it, right? Like people that will dive into performance issues like memory with value types versus pointer types or slices and structs and pointers, and for the most part, it's not going to matter for your code. Like computers are really fast these days. Like for most of the problems people are solving are actually really fast to solve. If you're working at a very large scale and the Googles of the world or the OpenAIs of the world, yeah, you're going to worry a lot about that performance. But for the most part, it's not you. That's not the problem. And if you're writing programs where like you pass in a parameter and you don't modify the parameter is immutable, and you receive back a value and that value is immutable, you don't really have to think about memory allocation terribly much. It's when you start modifying your parameters to functions that understanding a little bit more about that becomes important. And when you're using a standard library, like the way you read from a stream in Go, when you open up, you have a IO reader. That read method takes in an array of takes a slice of bytes in, right? And it populates that slice of bytes. So you're seeing this modification of your parameter that came in. And they do this to be efficient with memory usage, right? You don't return back the next chunk of memory because then you're constantly allocating more memory. You're reusing, like dipping a spoon into a river is what I keep thinking of it as. Like dipping in and taking it out, dip it in and take it out. And as long as you're just like, this is the pattern, don't understand it, don't just use this pattern, it's fine. Or marshalling, like reading and writing JSON in Go, right? I got to pass in this pointer to the struct, it'll fill it in for me. Again, I'm modifying my parameter. As long as you just like follow the pattern, don't think about it, you're fine.
Mm-hmm.
But then you're right, either A, you want to understand it, or B, you have to write your own code that does something similar. And that's when, how does all this memory stuff actually work behind the scenes? It starts mattering, right? So that's why I think I mentioned before about the interfaces and how interfaces work and having nil. It's the same problem. Like as long as you just like follow the pattern, you're fine. Don't have to think about it. You're good. But once you try to use it yourself, or like, why did this thing break in some weird way? Why do I have to do it this way? That's when how the memory works under the covers actually does matter. And part of this is Go's secret weapon, right? Like having that control of stack versus heap is let the garbage collector be a lot stupider in Go, which is a good thing, right? Like the more time spent garbage, like your program should not primarily become a garbage collector. Like I've done this in Java programs before where you allocate so much memory that it spends all of its time in doing GC and like none of the time actually like running your program. Your program's job is to process data, not to like search for garbage. And so the fact that you can do this heap allocation versus stack allocation and control it gives you the ability to not have the garbage collector have to spend so much time doing work.
Yeah, also in this slicing, I think there are good parts in the book to like how to use append with the slice, because if you have if you like everything passed by value in the parameter and the function, but the slices actually, the mental model of the slices is actually passing. You're passing the pointer, like the data itself is the pointer. So even though you have the copy of your slice, they are pointing the same data. So then the slicing or changing the capacity of the slice, it's becoming tricky, right?
Right, exactly. And again, it's that model of what does it mean to have a slice, and this is where Java or Python or JavaScript is different because they're passed by value, right? So if we pass a list into a Java method, you modify the list. List is modified, right? Because I pass the pointer to the thing in. It's a pointer to the whole state of it, and they're all sharing the same data. And a slice in Go is this weird combination of two values and a pointer.
Yeah.
And so if I pass my slice into a function, I can modify the field. I can modify the data. But if I grow the slice, that's going to change my pointer. Or if I add another element onto the slice, but don't have to grow the capacity behind the scenes, well, that was in the copy that had that reference. So that when we pass it back again, that data has been stored in memory, but you can't see it because your copy, the calling function doesn't have its data, its copy of the slice modified. So they're pointing to the same memory, but they have different values for size. And I did a talk, Go Says What, at GopherCon 2018, I think, where I go through all these weird things you pass around slices or maps and like what's the weird behavior and why does it do these things. And again, if you're just following the pattern, just following the rule book, it's all fine. But once you just say, but why did this happen? Or I did a thing, why did it not change? That's when the actual memory model starts mattering. Abstraction is going to leak, and you just have to understand the lower levels to make it work. And at some level, I think we all just kind of say this is magic. Like I'm not an electrical engineer. I don't know how chips actually work. Mm-hmm. At a certain level, I'm like, yes, electrical things happen, and that makes a command run. But I don't really know how to build a circuit that's going to like run a load command that pulls data from memory. I just know that it does work, and I hope I never have to understand that abstraction layer ever.
Yeah, there's something related. Like I think that in the book there are lots of small small parts which is not related exactly with the topic, but like for example, you're explaining Unicode very well, like with the UTF-8, and that's one thing. For example, another thing in the hash table, so underneath the map is handled in Go as with the hash table, and you're given a lot of insights around that as well. So those kind of stuff is actually making your learning other stuff beside of Go, and those kind of stuff is actually went well with the book.
Thanks. Yeah, it's standing on the shoulders of giants. I didn't make up any of this stuff. I just learned about it and learned about it well, and it's important to understand like what's going on, I think. And the Unicode relationship with Go is kind of fascinating because Rob Pike was one of the creators of UTF-8, and they just, as the back of the napkin, they like sketched out this idea for UTF-8 while working on Plan 9, and Plan 9 is dead, but UTF-8 lives forever.
Yeah. So let's go to AI. So AI is getting better with the writing code. So what do you think about the AI's roles it's nowadays and the changes in the AI world and impacts on the development cycle of programmers?
I've been thinking about this a lot lately, and I think that there's something there. Like I think LLMs are really going to change software engineering. I'm not sure they're going to affect the rest of the world, but I really think software engineering is going to be impacted just because the training data is there. Like, we've literally trillions of lines of code now that's open source that is all available for training. And unlike if you ask an LLM to write an essay for you, you have no idea if what the information it pulls is true or false, or lawyers using made-up law cases in court. The program runs or it doesn't, right? Like we can tell in the end if the code actually does work correctly. So I think that gives us a nice little training function for using LLMs to get better and better at programming. So I think there's something real there. And I'm going to tell a story. This actually, LLMs remind me of something. There's an old programming story called The Story of Mel. I don't know if you ever heard of it before.
I think no. But
so this was first posted online like the early 1980s on Usenet. And it was the story of a quote-unquote real programmer from the late 1950s. So this is like a 70-year-old story at this point. Mm-hmm. I have a link to it I can share with you later. So this programmer, he wrote a blackjack game as a demo for this early computer company. And he wrote the whole thing in hand-tuned assembly. And this assembly would take advantage of how fast the drum, just drum memory, there was spin. And his programs would take advantage of how fast the drum was spinning for where the instructions were placed. And compilers did exist at the time, but he didn't trust compilers. His code ran faster than compiler code. And this blackjack program that he wrote had this loop that looked like it was impossible to break out of. And the story of Mel is all about this guy understanding how this loop really worked.
Mm.
And today, if someone was going to write a blackjack demo program for your computer and hand optimize assembly that no one else could understand, you'd fire them. You wouldn't say they're the greatest real programmer ever, right? Like, times have moved on. You just don't do this anymore. And I kind of think something similar is about to happen with LLMs. So moving to compiled languages did not remove the need to know assembly. They're still assembly language developers, but they don't do as much stuff in assembly, right?
Yep.
But that didn't get rid of programmers, right? Like there may be 1 million times more programmers in the world now than there were in 1956, when everything was written in assembly,
Yep.
right? And I think something similar is going to happen with LLMs, right? That the skill of writing code is going to move up the stack more to describing programs, understanding data flow, and there's still a place for people to do this, right? And there'll still be a place for people writing code directly and having an LLM write it for you. But I think over time that's going to become more of the exception rather than the rule.
Mm-hmm.
But the plus side to that, the flip side of that is that there's going to be many, many more people making software. And the software they write will solve their problems. And that's kind of great, right? But there's yet another flip side to this, right? Like I talked about Zig before, and I said I'm a little concerned about it. I kind of think we're going to start seeing the end of new programming languages. Zig is new. There isn't that much sample code out there. There's still changes to like a 0 point something version of Zig. They're still making changes to the language. How do I train an LLM on that? And if a brand new language comes out, there's no training data. How does an LLM learn how to like code in that language? I think Apple's done some research into how to like generate training data for new languages because there's not that much Swift code out there or Swift UI code. But that's maybe a way out. But is that going to be important? Like, are people just going to like stick with the languages that we have tons of code in right now and use those languages more or less for forever? Because that's what the LLMs are all trained on. And that's what they're all going to generate. And that's all we're going to read. And if that happens, that's a little bit sad. Like for like the past 70 years, people are making thousands and thousands of new programming languages. And it's this great creative outlet, ways to think about solving problems. And that might be ending. I'm a little bit sad about that.
Yeah. But in your personal day-to-day life, you think the LLMs are capable of doing everything nowadays? Like for me, from my perspective, yes, I'm also using it for many things, but it's not giving me that much of confidence it can handle everything. And I don't even think it can happen maybe next year because, yes, it is doing 80%, 90% of things are very well. But then this 10%, 20% he's really struggling, or it is really struggling.
Yeah.
Yeah.
No, I agree. I think that they can. I think they solve they can do a bunch of the work, right? There's always been this very repetitive part of programming, right? Like these are solved problems. You know how to like build and intercept. You know, like I know how to write a HTTP listener that's to handle a request. I know how to write a handler that's going to intercept the request and handle load for it or attach permissions to it or look it up in a database so I can pull in who the user is, right? That code has been reinvented 100 million times, right? And there's samples of that code out there, and no one has to write that code again at this point. Like that kind of code is not going to be a problem anymore to write again. And I think that's fine. Like again, like compilers are going to take care of, I need to write a function call. Like a function was a cutting edge thing at some point. Oh, the assembly's got to write, I got to put things in the stack in the right place and load into the registers in the right place and do a jump and then return and copy things back out again. And there were people who were really good at doing that. Like Mel was fantastic at writing this kind of stuff, 70 years ago. But a compiler can do it better for me now. And that's okay because that's hard to get. It's repetitive, and if you make a mistake, it blows things up. It's hard to know what's going on, right? And that kind of code, I think LLMs are going to pick up for us. If they haven't already done it for you, they really could. But what problem I'm trying to solve, is this actually solving this problem in a good way? You still need a person for that, right? Like, there's still a good software engineer is still necessary. I still have to understand, like, writing the good plan is important for the LLM. Like, here's the exact problem I'm trying to solve. Describe it well, which has been a problem in software engineering from the beginning. Like, if you've ever written like a big requirements document and given it to somebody else, have them implement the code for you, and it comes back, it's like, that's not what I meant. Right? You didn't write the requirement well enough. I think it's the same problem, only now it's a computer instead of a person who's doing this. And you have to figure out, how do I chunk my work up so that it slowly builds building blocks, I describe it well, and they're testable chunks, and I'm sure this is actually going to the right place, right? So yeah, today we're not gonna just like type in and say, build me a video game, and here's the video game, right? They can't do that. But they can use parts of that, right? They can do some. I want to write an endpoint that will take in data, and the data will be formatted like this, and it will needs to store it in a database, like in the table looks like this. And you can get most of that correct today in an LLM, and that is huge, right? I think I have a hope. Like I don't know if this is actually going to come to fruition. That today we have software companies have kind of like when I was when I was first learning to program, 80s and 90s, there were tons of small software companies. They had one or two products, a couple of people working on it, and those are mostly gone, right? We have really big companies doing software on the web, and small little software companies are a dying breed. They're not. They're labors of love. They're not really like good businesses to be in. And I kind of wonder if maybe having an LLM and one person or two people in an LLM writing some bunch of code hand us back to that world. We're able to be as productive with a couple of people who are pretty smart and can look at the output of an LLM and use it to tweak and build customized software for people and get that flowering of millions of companies again. Where again, people are necessary; they're an essential part of the process. But a lot of that work that just requires now legions of people to correctly do really boring coding goes away. So
Yeah. So maybe lastly about that, you think the LLMs are going to come to the stage they can handle everything? Because like nowadays we have everything for us, like programmers, like TCP, UDP, all the protocols, HTTP, based on to our understanding. But maybe if the LLM come to the level of, let's say, AGI or something, then would it be necessary to have these protocols communicating with each other in this level, or there will be any change, or you think it's far ahead and yeah, it's less likely?
um, I don't think things like TCP or UDP I think are just kind of baked into our world at this point. That that's not going to change no matter
Mhm.
what. Just they won. Like they were the protocols that ended up being the way we talk to each other, way computers communicate. They're not going to go anywhere no matter what. Um, I don't know if AGI is going to happen or not. I'm not even sure if we'd recognize it. Go back 15 years and people talk about the Turing tests and oh, you pass the Turing test, you're intelligent. Like I don't think there's a person who can argue that LLMs they don't pass the Turing test, but I also wouldn't call them intelligent, right? So
Mhm.
we had this like we had a model said, oh, if you can do X, clearly you're intelligent. Well, we did X. It's like, oh, never mind, you're not intelligent. We're gonna move that line a little bit further now. And I don't know what the line looks like. I don't know what AGI really means and becomes.
Mhm.
Um, so I'll punt on that part of it because I don't even. Not saying it's not a good question. I think it's actually going to be like the question at some point. But I don't know. Does it have a soul? That becomes really the question in the end. And that's someone's higher pay grade than mine to figure out. I think. I do think that there's certain like even today, like even higher, like I said, talk about leaky abstractions. No matter what, you still need to drop to lower level things. People writing device drivers, people writing firmware, they're still writing in assembly. Or they're writing on some low level language. There's still people doing that. That hasn't gone away. As
Yeah.
people are able to use better languages and more easy to process languages to build higher level software, right?
Mhm.
So I think no matter what, where LMs get to, there'll still be a person doing some part of it. There'll still be some need to write code by hand. There'll still be need to write assembly,
Yeah.
but it won't be as much. I think that's kind of where the world we're going to look at.
Okay, lastly related about that, because last couple of weeks it was going on debate about junior developers. I think the AWS CTO or somebody from AWS was mentioning to breaking the junior developers out of the line is gonna give a lot of harm to ecosystem because of like in 5 years of time, if you don't have junior developers to train and make them to work in the real world problems, then you won't have any enough developers. Like for example, in Go, there are, I think, like according to JetBrains, there are like 2.2 million Go developers currently. If it's not raising, then it will be problem. And if the LLM is not going to be able to take care of a lot of things, then it's going to be really, really problem. What do you think the removing the junior developers from the ecosystem, what would be the consequences?
Uh, I think it's bad. I mean, th- this is a while ago. So, company I worked for about a decade ago, New Star, brought in one was professor, I think at MIT, who had been a fighter pilot at one point, and she left when she said in her talk, remember this correctly, that she left the Navy, and she was a fighter pilot in the Navy. When she saw the planes doing the planes had the landings, doing the landings on the aircraft carriers, apparently it's the hardest thing in the world to do, and they had the computers doing it. It's like, oh, what's the future for fighter pilots when the planes can land themselves? Like that's the hardest part, and they're doing that already. And she's like, I better get out of here, and she did. And I kind of I had the same thought when I first heard the story like 10 years. Like, so who are to be the new fighter pilots, right? If we are going to have this world where the planes are so good at this, well, great. We still need fighter pilots, don't we? Or maybe we don't. Maybe there'd all be drones, but I don't think that's true. I think there would still be people in planes at some point. So I think the bar on who becomes a fighter pilot probably goes up. I think the bar on who becomes a software engineer probably goes up. That you don't need as many software engineers, right? That I think probably the world we end up in is the people who are doing that kind of low-level work where you need a software engineer who has a strong background in computer science. The number of those positions may be shrinking because the LLMs are doing some of that work. I think people who just go into code camps and spend 6 weeks and now you're a JavaScript developer, I think that's a dead-end path now because the level, not that those people aren't smart or capable, it's just the level of training you can get in 6 weeks or 6 months in how to program is not the deep enough knowledge to understand the whole system view you're going to need as you're using LLMs to do the same work. Mm-hmm. And so in that case, yeah, those junior developers are going to go away. I think if companies are like, oh, we're not going to hire any juniors anymore, they're going to run into the exact problem you just described that AWS is describing, where who are my future seniors if I have no juniors? I think what you're going to find is that people who know this well and know the topics well and they know that full stack and they know where the LLM is working well and not working well are the people who are going to succeed as software engineers in the future. And this is harder, right? This is without a doubt a harder path than the last 30 years. I've been kind of lucky in my career. I started working just as the dot-com boom took off, and it's kind of ending now just as LLMs are coming in to replace software engineers for a lot of jobs, right? So it's perfect timing for needing lots of software engineers and maybe not needing as many. So I don't want to brag about my good luck for my career. But yeah, I think it's just going to change what the nature of the job is, how many people are going to do this. And that might be good. Like I said, there will be more, like I said before, I think there'll be more people making software. I think fewer of them are going to be software engineers.
Mm-hmm. All right. Thank you, Jon. I think we covered a lot of things and I hope everybody enjoyed. Thank you for coming to the show. And yeah.
Yeah, thanks, Mustafa. This is fantastic.